Sorry about that. Okay, so good morning again. I'm Pedro Menandro. My title of presentation today is the Multispectral Backscatter, advantages of using a multi-frequency methodology for rhodolith mapping, and an overview of ongoing projects that engage backscatter in Brazil. So it's two main parts of the presentation. It's not a full paper. It's just to show what is being done by our group here in Brazil. So starting with the rhodolith mapping to contextualize, despite being one of the backscatter working group, the multispectral backscatter necessarily permeates other teams, especially those of acquisition and processing. Multispectral backscatter has been developed to improve that classification in greater detail, yet the methods for the use of this data are still being explored. So detailed understanding of marine habitats is required to meet multiple ocean management needs, and accurate habitat classification based on backscatter have already been able to present fine-scale characteristics of the seabed. And one of the gaps that still persists is the difficulty in distinguish acoustically similar seafloor types, such as mixed bottom and rhodolith. There are a few studies about rhodolith mapping, and although these rhodolith beds have a worldwide distribution, the scientific research on rhodolith is still relatively limited if compared to other coastal vegetated habitats. And if we consider rhodolith studies related to acoustic mapping and backscatter, the catalog is even more limited. So here is just to show two examples that mapping polymetallic nodules and rhodolith beds using backscatter data sets. And both find that the variation of the backscatter values is not in according to the size or the concentration, the density of the nodules and rhodoliths. So the main objectives to this rhodolith mapping is demonstrated through supervised classification techniques, the supported vector machine, the advantages of multi-frequency data compared to a single frequency, and also analyze the importance of the angular response parameters in rhodolith recognition. So the data set is shown here on the left. The bathymetry ranging from 44 up to 100 meters. So we defined 3 polygons to further investigation, and the backscatter mosaic for the 3 frequencies is shown here: 170, 208, and 400 kilohertz. The equipment is the R2 Sonic 2024, and the processing was carried out in FMGT. Okay, so the RGB composite image with the 3 frequencies, and note some variations. And here, the another part of the data set, we have 33 stations of drop cameras images. And based on the coverage of the rhodolith, we defined 4 classes to train the model. So no rhodolith, lower than 15%, between 15 and 30, and more than 30% of the rhodolith coverage. This rhodolith coverage was calculated in the image J2. And above on the slide, some of the examples, many rhodolith in this area is MPA region, with many rhodoliths. Okay, so here the first part of the preliminary results. We run this SVM classification, use each frequency separately, and then with the RGB mosaic. We can note the RGB classification achieved the best cross-validation rate and the better discrimination of the C4 class. And also that for the lower frequency, we can note a better discrimination in the north area. And for the higher frequency, we can observe the higher differentiation in the south area. In the north area, we have more rhodolith. Okay. And for the second objective, about the angular parameters, to investigate the importance of angular parameters, we have two types of data sets results. So first, the corrected backscatter values for each 10-degree range sector. So here the colors indicate the nadir up 10, 11 degrees up to 20, 21 up 30, and 31 up to 40 degrees. And in addition to this, we have the angular response curves for each sample station. Here is an example of angular curve for each frequency in a point with high coverage of rhodolith. We can note some difference in the frequency. The 208 kilohertz, it's a very low loss of backscatter according to the angular incidence. The lower frequencies show lower backscatter values, and maybe because of the rugosity of the seafloor, but it's much to be explored yet in these results. And for the second objective, I start some conversations with Alex Bastos and Ben Miziuk to define which method we could apply here. So the first test is the classification and regression trees using just the angular results, but it's not so good yet. And another test was the random forest to measure the importance of each variable, but still being explored. So the next steps is define the best approach to analyze the importance of angular features, then compare these results with other works, and try to establish a multispectral response model for rhodolith beds. So these works in the table already found out some important results in terms of backscatter for rhodoliths, and then the manuscript. Okay, so now for backscatter in Brazil, I'll show some data. So in the Peter Harris Geohab Atlas, we can note that backscatter is one of the most useful and collected data set for habitat mapping. And in this same atlas, we have 7 chapters from Brazil. Just 2 using backscatter, but from side-scan sonar, and no multi-beam backscatter data is applied in these 7 case studies. So it's important to emphasize that traditionally the term backscatter is still more associated with the more widespread use of side-scan sonar in Brazil. So many people, mainly from companies, hydrographic companies, do not even know how to work with backscatter. So I would say that Brazil is definitely not the backscatter paradise. So although today this bathymetric grid from JEBCO, 32% of this DTM is composed by multi-beam bathymetry, but the backscatter data is unknown or even not recorded. So backscatter research here in Brazil is carried out by few groups, even with all the difficulty of funding science in Brazil nowadays. And considering the main terms of the backscatter working group, I would say that backscatter in Brazil is more focused on the data processing calibration with Professor Luciano Fonseca, and the multispectral backscatter, but always as background of the CBAT classification. So here are just some examples with backscatter data in Brazilian studies. This Rio Grande rise that Luciano Fonseca already showed us some data set. This data report with Luigi Giovanni et al. With some backscatter data collected. Here are another examples of our group here in Federal University of Espírito Santo. The paper with backscatter single frequency, but multi-beam backscatter, classifying the concentration of rhodolith in accordance with the variation of the backscatter using image-based analysis. And more recently, a paper with participation of Professor Craig Brown and Ben Nizio, applying a multi-method framework to analyze multispectral backscatter. So here we applied first a segmentation in RGB mosaic, and then a dense cluster, a dense-based cluster with many variables, image-based and angular-based analysis. Another examples with data collected outside of Brazil, so the works with Professor Luciano Fonseca, the angular range analysis, some works with data collected in Antarctica, and more recently we have this paper, important piece of work for our group. So it's a classification, habitat mapping classification. Using bathymetry, backscatter, cameras after a main industrial disaster. So it's a dam failure with many tons of tailing in the Dulce River mouth. So we're mapping a huge area with bathymetry and backscatter. So here's some of the data set collected. So today it's around 1,200 square kilometers. So all this data set is multispectral and our regions with backscatter. So it's a huge amount of data, not yet fully analyzed. In a range of seafloor, so we have heterogeneous MPA. We have an area with many reefs. We have an area close to the Dulce River mouth. So it's any work to be done yet. And here is just the database we are online, not yet available, but we intend to put this database available. So we have the bathymetry of the continental shelf, not multi-beam, it's the interpolation, and then in detail the bathymetry, the multi-beam bathymetry, and the backscatter. Now, this area is close to the Dulce River mouth, bathymetry and backscatter, and for the north, the reef areas with many reefs. Okay, so the future projects is the continuity of this current project. So we have at least 1.5 years for collecting more data. And another plan is the wind farm application for with one of the work package being focused in seabed mapping and classification, use multi-beam bathymetry and multispectral backscatter. So yes, I think it's pretty much all I have to talk to you. Thank you for your attention.